He didn't show up, so now you get me. And I'm going to talk about distributing open source software, specifically how we do it at Alma Linux. My name is Jonathan. I'm the infrastructure lead at Alma Linux. I'm a Fedora contributor, packager, sponsor. I sit on the EPEL steering committee, that's Extra Packages for Enterprise Linux. And I've been doing open source for about 20 years, about 4 or 5 of that where I've been actually contributing. I've got a whole lot of slides here. I prepped these slides like 30 minutes or so ago for a last minute thing. So I've got a lot of slides. We're going to move through them pretty quick. I trimmed as much as I could. So how it started within Alma Linux, we didn't have a mirror system at all. We had a single server serving all traffic. There was no fallback for it, and we were getting a few thousand hits per hour. Pretty basic stuff. It was literally just an Apache web server serving files. But when Alma Linux started, we had no users. For anybody not aware, Alma Linux is a Red Hat derivative, or at least that's how we started out. And when the changes around CentOS happened several years ago, that's when we came to be and how we kind of grew into something very rapidly for people that were looking for somewhere to migrate to from CentOS. So where we're at now, we've got a network of over 400 mirrors worldwide. We've got over 1.7 million installs that are hitting our mirror system, our public mirror network, every single day. Many more systems are out there that we know of. They're using private mirrors, so we don't see their traffic on our public mirror system. We've estimated the total Alma Linux installs at over 5 million, and we're processing about 2 million web requests per hour to our mirror network. We've got automatic horizontal scaling and custom mirrorless software that's kind of orchestrating all of this. All right, so the story of how we got here, this is just a kind of a usage graph over time, or rather a graph of the number of unique systems hitting the mirror list over time. So how did we get to this point from where we started with just one simple web server distributing software? It all starts with a tier 0 mirror where we push updates after we've built them for Alma Linux. They go to repo.almalinux.org. And from there, it's kind of a keep it simple, stupid type architecture. That is one server that then pushes to a network of 3 servers. And then all of the 400 global mirrors that I was mentioning, they rsync from that network of 3 servers using DNS geosteering. Here's kind of what that looks like. We've got our rsync servers in Seattle, Atlanta, and Amsterdam. Atlanta was the first one there. It's kind of sad these days at only 10 gig, but it's about to get another 0 on that speed, and then it'll be a lot better. But yeah, those 400 mirrors, they hit these mirrors, pull their information, and then the orchestration system, the mirror list, if you will, serves a list of those 400 mirrors, again, using some geographic steering to get people to mirrors that are close to them. This is kind of a shout out. Kenneth Finnegan, he runs something called the Micro Mirror Project, and they're taking these little low power, almost like NUCs, those little HP Lenovo thin client-esque things, and they're shoving 4 terabytes, 8 terabytes of SSD in them, and they're sending these things out to data centers and basically anybody with good bandwidth all over the world or all over the country that they can get to host these things. And they're serving distros, everything from Fedora to Ubuntu to Arch and Debian and whatever else off of these things. And some of them, he's got pictures of these little boxes that they've shoved into like roadside fiber distribution boxes. So you've just got the side of the road, and this door is open on one of those cabinets from an ISP, and they've got an Alma Linux mirror shoved in there. So it's really neat, the project he's doing with no budget. All right, so looking back at the start, February 2021, this is kind of where everything started. CentOS had announced the change to CentOS Stream at the end of 2020. So in February 2021, we're kind of gearing up for the initial Alma Linux release, which ended up being 8.3. But it was the initial mirror system, had very little logic, actually no logic. It was literally a text file list of mirror URLs. There was no status checking, nothing like that on it. And there were You can see over the course of about a month, we got up to about 30 mirrors, from 2 to 32. This is when the news is real active. We're looking for mirrors to get the stable release of Alma Linux out. Going forward into March, like I said, Alma Linux 8.3 stable was released on March 30th, and as of March 31st, we had 54 total mirrors. It's pretty good. Distro just had its first public release. That's not bad. That was plenty. Like I was saying, the system was dumb. It was literally a text list of URLs. So it was very possible if a mirror got out of sync or out of date, if their syncs broke, that we're serving these update URLs to these user systems, and they're going to run into errors. That's obviously no good. So had the 8.4 stable release in May. By July, we're up to 128 mirrors. That was just phenomenal at that point. But things are getting unwieldy. This was that text list I was telling you about. It was managed by hand in Git, adding and removing URLs. That was not going to scale. that wasn't going to work at all. So going forward to July, we released what was kind of the first iteration of what we now call the mirrorless system. It's written in Python. It's a geolocation-aware mirror system, so it tries to serve a mirror close to you. We had basic mirror status checks so that we could automatically pull out busted mirrors so that we're not serving those to users. And Andrew, he's our lead architect, the guy that was managing that mirror list originally, could take a break. This was before I came on board. The mirror list is kind of my project now, but in July of 2021, it was still Andrew. From August to October, we added a lot more features to it, ASN and subnet pinning, specifically for the cloud providers. If you've got a VM within AWS, it makes the most sense if we're serving you updates from within AWS. Same thing for Azure, GCP, so on and so forth. And even just beyond cloud providers, that's relevant to any large consumers of Alma Linux, especially those with perhaps limited download connections. So it could be a college campus. They're going to have heavy download traffic patterns already. If they've got a bunch of their labs running Alma Linux, and they can host a mirror and get that traffic internal instead of having say 100 unique Alma Linux servers all downloading the same stuff over and over, send that traffic to your local mirror, save that download capacity. So yeah, we can pin that with ASNs, with subnets, in a number of different ways. We had some bugs in this, and we had some mirrors in some locations that were just getting hammered. Let's take Atlanta, Georgia, for example, or let's say Austin, Texas. We had mirrors here in Austin, and there was no randomization among the mirrors that were in Austin. So we had the same one getting served first every time. So that that one mirror for this geographic area would just get hammered. So an easy fix to that, randomize the mirrors within a geographic area. November 2021, things are still moving forward. We add some caching layers, flap detection, better geolocation. I'm going to start moving through these pretty quick. 2023, we had 4 Alma Linux releases. We increased the VM size to get cache hits better. And then we run into another issue. The mirror list could be different between VMs. We're horizontally scaling at this point, but not very well. We have basically 3, 4, 5, 6 different instances of the mirror list running that are all doing their own logic, their own checking logic to see what mirrors are online, what mirrors are offline. So you could sit there and refresh the mirror list over and over and over, and you could get 5 different results. It could change every single time because each one of those servers was doing its own logic. So we had to get better, pull that from, say, a common, it started out as Redis, now a common Valkey cache that all of the mirror servers were sharing, and kind of centralize the status checking of mirrors and make the servers being used to actually serve the traffic more stateless, if you will. So that added a lot of efficiency. Continuing on into later in 2023, that talks about the singular cache for workers that I was talking about. We ultimately moved it to AWS Elasticache, originally on Redis, now on Valkey, and just drastically improved the performance of the mirror system. Here's kind of a representation of when we did that, and you can see the response times went down from almost a second on having to crunch on all of this logic down to minuscule amounts. The graph doesn't really show it, but it's down to basically 100 milliseconds or so, and up from an average of we'll say 800 milliseconds. That was significant. We were using MaxMind for the geolocation data, which comes with its own set of problems. One of the things that we started running into, here's a GitHub comment that stemmed from something somebody said in our chat. It was a mirror owner, and they're like, hey, I've got a mirror in, I believe, Kansas, and it is getting absolutely hammered. My 1 gig port is just completely maxed out. What's going on? I'm in Kansas. So we're like, that's probably not good. Here's what we discovered. Looking at all of the traffic that we were serving, MaxMind would have you think that the most ALMA Linux users in the continental US were in Kansas. Something tells me that's not right. As we found out, MaxMind, when it doesn't know specifically where an IP address is, it puts it straight in the center of the geographic United States, which is Kansas. Kansas is not an internet hub at all. So we had 3 mirrors there getting absolutely obliterated. It was quite terrible. So we realized the shortcomings of MaxMind, and we started looking for a better solution. We discovered IPinfo, started talking to the guys at IPinfo. They were happy to contribute their data. It is commercial, but they were happy to share it with us. Now the chart looks like this. That's a lot more what you'd expect. For anybody not aware, right around the Virginia, Washington, D.C. area is the internet hub of the U.S., and that's what we expected to see. So now we're distributing traffic a lot better. This improved the user experience of mirrors a ton, because it wasn't just IPs in the US that were being pinned to the wrong location in the US. They were pinning IPs from Europe in the US, from US to Europe. So we had traffic flowing everywhere, just not in great ways. Yeah?
Do you have any characterization of how much better IPinfo is versus GeoIP?
Versus MaxMind? Better in what way? Like accuracy? I've never found a single IPinfo record that was more than like 200 miles off of where it actually was. Like I don't even know how to compare it. MaxMind, I would say, was probably 15-20% wrong. IPinfo, maybe 1%. I mean, it's solid. All right, I had to throw this in. So remember, I mentioned when we did a bunch of the caching work, we got the target response time down to about 100 milliseconds. Then we found more. If you look at the graph on the top left here, we're taking the target response time down from about 50 milliseconds to it's about 15, which is huge. How did we do that? Avoiding a disk read on every request, reading the config file. We cached that in Valky as well, and what do you know? Performance improved. Disk reads are heavy and expensive. So not only did it decrease the response time, you can see what it did to the CPU usage as well. And that decrease is while also decreasing from 64 CPUs down to 16. So it worked out to about a 97% decrease in infrastructure for doing that. So the takeaways that we've discovered along the way: traditional mirroring is amazing for free and open source distribution. When you are producing something that gives value to people, and it's free and open source, people will step up and give you mirror infrastructure. Those 400 mirrors I mentioned, that is 100% people stepping up saying, look, I've got some spare space on this server, I've got bandwidth, let me serve ALMA Linux updates, and help my general area and help ALMA Linux overall. Come out of the woodworks. For us to have 400 mirrors is phenomenal, and the mirror owners do more for us than they could ever imagine, because trying to distribute the amount of data that we distribute for updates and releases, I don't want to know what that would cost on something like a Cloudflare or a Kami or a Fastly, whatever CDN you're talking about. And traditional there is going back to that keep it simple, stupid principle. We don't have all these layers of abstraction and shared file systems, or your Ceph or stuff like that, because it's just not needed. All that does is add basically places for failure. And we've watched other open source projects try to do stuff like that and found there's no need. The way open source mirroring has been working for the past 30 years, and it's remained largely unchanged, that's all we're doing now. There's a little bit of orchestration on top of that, the GeoDNS and the geolocation for matching the mirrors. But that's really about it. Underneath it all, it's still rsync. We're pushing the files from one server to 3 to 400. And that's basically how it's been for 30 years for Linux distros, and I really see no reason for that to change. The accurate geolocation data improves user experience a ton. After we moved over to IPinfo, those mirror owners in Kansas were incredibly thankful. They got their pipes back. They weren't being saturated with traffic from Europe. Coming up next, we want to do more statistics. The heat maps in this that I had created, those are actually part of a development version of the mirror system that I'm working on, to where we can generate those maps live and display those all the time, have them updated. So we just got to get that finished. It'd be cool to do a breakdown by country. What areas could we use more mirrors in? Where we geographically have a lot of traffic but not a lot of mirrors. There's all kind of cool statistics that we can pull out. So I want to keep expanding on that. The development environment is a little bit lacking. This is all written in Python and wrapped in Ansible, and it's not very user-friendly to set up a development environment. The code base itself is pretty straightforward. It would be pretty easy for a Python developer to come in and contribute, add code. But the way things stand right now, that is very difficult. So we want to improve that. Protocol filtering, we had some requests for people to only be able to tell the mirror system, hey, only give me mirrors that support HTTPS. I don't want to get into why or why not, that's good or bad or whatever, but we added that ability, and we took it a step further. People can request mirrors that only have a full ISO set, don't have a full ISO set, only exist in a certain country, for compliance reasons, or what have you, various filterings that you can feed into the system. Partial mirroring is another big one. Right now, the full data set for an ALMA Linux mirror is about 1.5 TB, and we want to lower the bar of what it takes to be an ALMA Linux mirror. And one way to do that is allow people to run only a partial mirror. Say their infrastructure is only x86 or it's only ARM. We want people to be able to mirror only x86 or only ARM without having to pull PowerPC and mainframe code, for example, which is not exactly common. And better mirror validation. The way we check things now, we've never had major issues with checking the validity or how up-to-date a mirror is, but there is room for improvement. Right now we're doing it with basically some HTTP head requests and some hash validation. I want to improve that further and give mirror owners the ability to say, here's the rsync URL to my mirror, and then we can crawl the whole thing with rsync and basically validate it all. Trying to do that with HTTP would be a big mess, and mirror owners would hate us. But doing that with rsync would be fairly lightweight. Here's some ways that you can get involved. Mirrors.almalinux.org, that is the public mirror list that will give you, a listing of all of our current mirrors, about the 400 I was mentioning. There's the GitHub URL to where the project is managed, and barring these, if ALMA Linux is not your distro of choice, that's totally fine. If you have the capacity, give a mirror to whatever projects you are using. It helps, like I was saying, more than people could possibly imagine. Specifically, I want to give it a shout out to Fedora and EPEL. They do not have as good of a mirror network as ALMA Linux, but they should. They're the granddaddy of it all. Without Fedora, we wouldn't have Red Hat, CentOS, EPEL. EPEL is huge. None of that would exist without Fedora, so they need some love in too. And that's it. We got through that pretty quick, so I'd love to take some questions. Oh, I think we have a microphone. Eventually. Come on, Judd, run.
Hello, good talk. Thank you very much.
Thank you.
I was wondering, how do you handle collisions on the metadata when you're doing an rsync? Like if the RPMs sync first, but the metadata hasn't synced yet, or vice versa?
So there's an rsync flag for that, and it's basically delete after and update after, so that it doesn't do. Basically, it does the rsync into a temporary directory and then updates everything in like one IO transaction at the very end of the rsync.
Okay.
Yeah. A lot of distros don't do it that way, and then they do run into that issue. But it's literally just an rsync flag to solve that problem.
Actually, if you want to talk about that further, I used to run a mirror set for a company that just left. I can get way in the weeds for that.
Any other questions? Cool. Well, thank you very much.
Real quick, y'all. We have the final remarks for the closing at 6 o'clock over in Big Tex. Please join us over there for just a few minutes. If for some reason you leave before that, there's an after party at Lavaca Street Bar. There are 2 Lavaca Street bars. It is the one on Rock Rose or the Domain, whichever way it lists in your map finder. Do not, if you are driving more than 5 minutes from here, you're going to the wrong one. Please make sure again, because it is way far south, and with traffic, that's a long, long, long way. It's at 7:30. Please bring your badge. Thank you all very much. We could not do this without every one of you. Yeah. Don't buy your own beer. That's the whole point.
Is there food there too, or should we eat first?
I know they have food there. I don't know the logistics, and I knew that question was coming, and I did not find the answer out for you how that was going to work. I assume we're buying all the alcohol and you're buying your own food. I do not know the answer.
Okay.
But I do know they have food to answer that question. I would eat before I go to be.
Yeah, there's a big amount of time, so.
Well, and not a real nice thing to say, but if I were going, I would get food somewhere else first. I think that says what I'm trying to get across. Thank all of you.